The muscle tendon unit involves the connection between the muscles and tendons through which contractile forces are generated and transmitted, allowing us to move. In bouncing movements like running, jumping and hopping, the muscle tendon unit acts like a spring, in that the muscle tendon unit stretches as the lower limb joints undergo angular flexion before any tissue shortening occurs as the joints extend. In this way, the stretch-shortening cycle is facilitated by the storage of elastic energy that is used to potentiate further movement beyond that movement that was initially performed. A key mechanical property governing the spring-like behavior of muscular tendinous tissue is the term stiffness. Stiffness can be simply defined as the resistance of a system, for example the lower limb, to a change in length. Stiffness can be calculated as the ratio of the applied force to the change in length. During spring-like movements, the stiffness values of passive tissues, i.e. tendons, and active tissues, i.e. muscles, are integrated with neural messages to enable the body to act like a spring. Stiffness can be quantified directly or indirectly. An athlete who improves their ability to act like a stiff spring can enhance a range of sporting movements, such as vertical jumping, endurance running, sprint running, and change of direction tasks. This is because, to effectively perform these movements, the body leverages the stretch-shortening cycle, which exploits the elastic characteristics of the muscular tendinous unit as it absorbs braking forces at ground contact and generates propulsive forces at push-off. This process therefore takes full advantage of the spring-like behavior of the muscular tendinous unit, as the kinetic energy generated enables faster movements to be achieved. In the article published in the Journal of Sport and Health Science, Jason Moran and colleagues conducted a meta-analysis investigating the effects of plyometric jump training on lower limb stiffness in healthy individuals, and in doing so put forward plyometric jump training recommendations when the goal is to enhance lower limb stiffness. This presentation, brought to you by Talking Sports Science, will be a summary of their research. Firstly, regarding the study criteria, studies were only included in the analysis if the plyometric jump training program lasted 3 weeks or more, performed by healthy individuals of any sex or age, with at least one measure of direct or indirect lower body stiffness recorded pre and post training, which was then compared to a control group. In the end, 12 studies involving 16 experimental groups met the criteria and were included in the analysis. A total of 7 of these groups incorporated measures of indirect stiffness, and 9 of them incorporated measures of direct stiffness. For a breakdown of the types of jumps completed in each of the experimental groups, I recommend you go and take a look at Table 2 within the article. Moving on to the findings, the results of the analysis revealed that plyometric jump training can induce a small but statistically significant increase in lower limb stiffness. As a caveat, the increase in lower limb stiffness is likely influenced by an individual's training status. For example, untrained individuals experience larger increase in stiffness compared to their trained counterparts. Also, in comparison to traditional resistance training or eccentric resistance training, plyometric jump training may not be the best way to enhance stiffness. Therefore, plyometric jump training may be better performed as a complementary method for enhancing lower limb stiffness alongside resistance training methods. Nevertheless, in terms of plyometric jump training prescription to enhance lower limb stiffness, programs lasting longer than 7 weeks, consisting of 1 to 2 sessions each week, involving less than 250 jumps per week, is suggested. This low frequency of jump training sessions, in conjunction with a low within-session volume over a high number of training weeks, is recommended to help target lower limb stiffness while avoiding excessive fatigue that could interfere with achieving other training objectives. In terms of jump selection, to enhance stiffness, it is recommended to include jumps that require resistance to knee and hip flexion and short ground contact times. For example, ankle hops, skipping, hurdle hops and depth jumps, which can be incorporated into a warm-up activity. As with all forms of training, plyometric jump training programs should follow a progressive approach to overload, according to the individual's capability. This could be in the form of volume, type of drill, intensity, or a combination of these. Also, the small gains in stiffness that can be attained through plyometric jump training are likely to be subject to diminishing returns over time, emphasizing the importance of plyometric jump training being performed in combination with other training methods. And that concludes this presentation regarding the use of plyometric jump training and lower limb stiffness. As always, I recommend you go and check out the full article. The link is in the description. Thanks for listening, folks. See you next time.